Introduction. In this very moment, as you watch this video, you are surrounded by an invisible dance of electrons, a silent exchange of atoms, and molecular transformations that happen right before your unseeing eyes. Welcome to Lecture 59 of our Unusual Science series. I'm your guide into the enigmatic world of everyday chemistry, the alchemy that permeates our existence yet remains cloaked in the mundane. What if I told you that your kitchen is not merely a place for culinary creation, but a laboratory of chemical wonders? That your laundry room harbors reactions so profound they would astonish the ancient alchemists? That your very breath is participating in chemistry, so complex we're still unraveling its mysteries? The world of chemistry doesn't exist solely in sterile laboratories with white-coated scientists. It surrounds us, transforms our food, cleans our homes, and even allows us to perceive the world through our senses. Today, we'll pull back the veil on these hidden transformations. We'll decode the molecular mysteries happening in plain sight and reveal the arcane science behind the ordinary. Are you ready to see your world through new eyes? To recognize the chemical symphony playing out in every corner of your existence? Kitchen chemistry. Let's start our chemical journey in the most common laboratory in your home, your kitchen. Here, you are not merely a cook. You are a chemist, orchestrating reactions with heat, acids, bases, and catalysts. Consider the simple act of browning an onion. What appears as merely cooking is actually the Maillard reaction, a complex cascade of chemical events between amino acids and reducing sugars that creates hundreds of new compounds, each contributing to flavors that didn't exist moments before. This reaction, named after the French chemist who discovered it in 1912, requires temperatures above 140 degrees C. It's not just cooking, it's molecular architecture. The same reaction creates the complex flavors in coffee, seared steak, and toasted bread. But there's something almost mystical about this transformation. The compounds created, furanons, pyrazines, thiophenes, didn't exist in your raw ingredients. You've conjured them into existence through chemistry. And what of the humble baking soda sitting in your pantry? This unassuming white powder harbors chemical potential that borders on the magical. When sodium bicarbonate meets an acid, perhaps the lactic acid in buttermilk or the acetic acid in vinegar, carbon dioxide gas erupts from the mixture in thousands of tiny bubbles, creating the cellular structure that transforms dense batters into light, airy baked goods. This acid-base reaction is perhaps the oldest controlled chemical reaction in human cuisine, dating back thousands of years. Perhaps most beguiling are the emulsions and colloids that surround us daily. Mayonnaise, that creamy condiment, is actually an emulsion, tiny droplets of oil suspended in water, kept from separating by the molecular architecture of lecithin in egg yolks. These phospholipids have a hydrophilic head that loves water and a hydrophobic tail that loves oil, allowing them to bridge the molecular divide between substances that would normally repel each other. The next time you spread mayonnaise on bread, remember, you're applying a complex colloid system that defies the natural order of molecular attraction. Cleaning chemistry, while delicious transformations happen in our food, far more sinister reactions are quietly working away beneath your sink. Chemical processes designed to dissolve, disrupt, and destroy unwanted substances. The humble bar of soap is perhaps chemistry's oldest cleaning innovation. What appears as a simple solid is actually a collection of sodium or potassium salts of fatty acids with a peculiar molecular structure, a hydrophilic head and a hydrophobic tail, not unlike the lecithin in our mayonnaise. When soap meets water and oil, these molecules arrange themselves into structures called micelles. The hydrophobic tails grab onto greasy dirt while the hydrophilic heads face outward toward the water, creating tiny spheres that can be rinsed away. It's a molecular trap, ensnaring the unwanted and carrying it away in the flow of water. A chemical dance that has been performed for thousands of years, yet most never glimpse the molecular ballet taking place on their hands. Bleach, a liquid so common yet so chemically aggressive that it demands our respect. Sodium hypochlorite, its active component, oxidizes chromophores in stains, breaking the chemical bonds that create color. But this reaction goes beyond mere cleaning. The same oxidizing power that removes stains can also denature proteins, restructuring the very molecular framework of biological materials. This is why bleach kills bacteria and viruses by chemically attacking their protein structures. When you clean with bleach, you're wielding a chemical agent so reactive it fundamentally alters the molecular structure of what it touches. It's not cleaning so much as chemical warfare at the molecular level. Chemical changes we can see. Not all chemistry hides in the shadows. Some transformations manifest before our very eyes, changing our perception of the objects around us. Consider the rusty nail, a visible testimony to oxidation reactions. What we observe as a reddish-brown coating is actually iron oxide, the product of iron's enthusiastic donation of electrons to oxygen in the presence of water. This electrochemical reaction transforms the very nature of the metal, making it brittle and weak. The nail isn't merely coated in rust, it's being fundamentally converted, sacrificing its metallic bonds in a slow chemical surrender to the elements. The changing colors of autumn leaves reveal another visible chemistry lesson. As daylight wanes, trees cease production of green chlorophyll, unmasking the yellow and orange carotenoids that were present all along. But the brilliant reds, those are anthocyanins, produced only in autumn, a final metabolic flourish before winter dormancy. Each leaf becomes a canvas for biochemical expression, a visible record of molecular changes triggered by environmental cues. In your home, silent crystallization processes occur constantly. The limescale forming in your kettle is calcium carbonate precipitating from hard water. Those ice crystals forming in your freezer, they're growing through the systematic arrangement of water molecules into hexagonal structures. Even the salt forming on the rim of a forgotten pretzel is testament to the natural tendency of dissolved solids to return to crystalline form as water evaporates. Molecular components seeking their lowest energy state through ordered arrangement. Invisible chemistry around us, but the most profound chemical ballet occurs entirely unseen, detected only through its effects on our senses and environment. The chemistry of smell is perhaps the most enigmatic. Invisible molecules fitting into specialized receptors in our nasal passages, triggering cascades of neural signals that our brains interpret as scent. When you smell fresh bread, volatile compounds like acetaldehyde and 2-acetyl-1-pyrroline are physically entering your body, docking with receptors in a lock-and-key mechanism that translates molecular structure into sensory experience. Air fresheners don't eliminate odors, they employ chemistry to neutralize them. Some contain cycloextrins, molecular structures with hydrophobic cores that can trap odor molecules. Others release counteractants that bind to odor molecules, changing their structure so they no longer fit into your scent receptors. Some even contain nerve-blocking agents that momentarily anesthetize your smell receptors. You perceive the absence of odor, but it's actually a chemical deception, a molecular sleight of hand. Inside your body, chemical reactions occur at a rate that defies comprehension. In each cell, thousands of enzymes are catalyzing reactions, building proteins, generating energy through the Krebs cycle, and replicating DNA. Your liver alone performs over 500 different chemical functions. The hemoglobin in your blood is constantly binding and releasing oxygen in a chemically orchestrated rhythm that sustains your existence. You are not merely experiencing chemistry, you are chemistry in motion, a walking laboratory of biochemical reactions so numerous and complex that we've only begun to map them. Conclusion: as we draw our chemical exploration to a close, I invite you to look at your world with new awareness. The steam rising from your coffee cup, the soap bubbles in your sink, the tarnish on old silver. These are not merely everyday occurrences, but windows into the molecular foundation of reality. Chemistry isn't confined to laboratories and textbooks. It's the language of transformation that whispers through every corner of your existence. The next time you bake bread, clean a stain, or simply breathe in a familiar scent, take a moment to acknowledge the unseen molecular dance making it possible. In these everyday moments, you're witnessing the same fundamental forces that form stars and shape galaxies, merely expressed on a more intimate scale. Until our next exploration, I encourage you to become an observer of the chemical mysteries hiding in plain sight. After all, understanding the chemistry of everyday life doesn't diminish its wonder. It deepens our appreciation for the elegant complexity beneath the surface of the ordinary. Music fades out, total word count, 1204 words.